All right, everyone. Welcome to the Robert Show. Super excited to be hosting today's episode. We're diving deep into benchmarks and not just any benchmarks, because we are talking about Firescale, Firebolt's brand new benchmark built to reflect real world production workloads. And I have with me joining Igor and Cole from Firebolt. First of all, welcome to the Robert Show. Super excited to chat a lot about Firescale. I've seen the announcement and I'm excited to learn more about the benchmark, how you all kind of came across, the results as well. So we're gonna deep dive into those things. But it's your debut, so welcome to the Robert Show.
Thanks for having us, Ravid. Great to be here.
Yeah, thank you very much. We're excited to talk about this. We've been hard at work on this for a pretty long time, and getting to share it with everyone is really exciting. So
Yeah, I can't wait as well. Obviously, when I kind of think about benchmarks as well, right? I've seen a lot of industries, a lot of companies always wanting to claim, that, and every vendor wants to always say they are the fastest and most efficient. But often these benchmarks sometimes kind of feel a little bit disconnected from the reality. Sometimes it does hit the hammer right, for the the enterprise leaders out there, for the architects out there, for the developers out there, and they feel more confident. So that's why I feel benchmarks have always been an interesting component, to compare, to go out and prove the value that you all bring to the table. So that's why when I heard about Firebolt, and I had obviously a great meeting with the team at AWS reInvent, and I think that's when you all were planning something. I didn't know about it then, but when I heard about Firebolt in your launching Firescale, I was super intrigued and super interested to chat. So without any further ado, let's chat, and let's deep dive into the benchmark. Cole and Igor. So just a quick question: why benchmarks? Tell us more about. Do they matter? Should anyone believe a vendor when they put out benchmarks, that will obviously favor the vendor itself, right? How do you all kind of, what's your take on that actually?
yeah,
Maybe Cole? Yeah.
yeah, so I think it's a complicated topic to dive into because it can be contentious. But
Yeah.
the reality is that, like, when you're evaluating possible options, it's
Hmm.
the first thing is that performance is one thing you want to consider, but not the only thing you want to consider. And the other thing is
Exactly.
that testing performance yourself as like an end user for many different competing systems is like either cumbersome or impossible or just unrealistic. You're not going to be able to do a POC with every single query engine database, etc., that may fit your use case. And a benchmark really is the only fair and scientific way for you to begin to understand, okay, how do these things measure up next to each other? Even if,
Hmm.
there are maybe concerns or flaws, it's the best try we have as an industry to give you a fair understanding of how certain things perform.
And maybe
Yeah.
I would add maybe just additional comments, actually two comments, and one to reemphasize, Ravid, what you mentioned earlier, which is when technology comes out there, people look at it and typically companies make claims, this is what technology does. So you really want to have
Exactly.
that proof point to say, hey, technology does this, and here is how you can actually validate the technology does what the company says. So that's kind of one data point. And the second one, as different users kind of start exploring the best and optimal solution for their scenarios. Benchmarks really allow them to kind of quickly scan and see, kind of look into the query, scan and see, does this actually match what I'm looking for? So people can actually evaluate various vendors and perhaps even select the vendors to go deeper into without spending actual money on evaluating, running the benchmarks from get going to select the vendor to work.
Very interesting, and thanks for sharing that. It kind of makes sense. Obviously, there has to be a place where, even like I said, the enterprise leaders, the developers, the architects, they want to at least go out and see, and you're from vendors, even if it's a little bit biased, but at the same time, there's a proof of point that is put into the report. So that kind of validates the things for the readers out there, and they feel more confident that okay, fine, they have certain use case that they are sharing. It's after of months of trials in the things that they've gone through, and then they have kind of come up with this report. So it makes a lot of sense. I also have a quick question, because we have seen, like, there are a lot of ways how you can put a benchmark together. There are already various places where we can find benchmarks in the companies kind of believe in. So why Firescale? Why develop a new benchmark? Like, because there are already benchmarks, standard benchmarks, like say TPCH or TPDS, um, um, or ClickBench, right? What was the thought process behind that? Any thoughts, Igor?
Yeah, that's a great question, Ravi. First of all, I do want to maybe acknowledge from get going that there are existing benchmarks that do provide, I would say, maybe standardized and repeatable way to measure query
Mm-hmm.
performance. However, these existing benchmarks, like they were built 20 plus years ago and do not really reflect the modern query patterns and specifically that modern AI applications exercise. What I mean by that is that these benchmarks really do not reflect and do not contain these low latency analytics in mind. They
Mm-hmm.
were built
Mm-hmm.
to kind of build to measure the query performance. Then queries run sequentially, one after the other one, which does not really represent how real-world applications functions and work, specifically in the modern era of AI, if you will. As an example, concurrency and throughput is really not something that these benchmarks typically focus on. And then as a result of that, they really and quite often underestimate the demand that workload actually can put on cloud data warehouses and data infrastructure in real life
Mm-hmm.
scenarios, leading to kind of misunderstanding and perhaps disappointments down the road.
Yeah. Anything else that you would like to add, Cole?
Yeah, I think it's maybe a little more specific, but like at least for ClickBench, participating in ClickBench is not possible if you're a cloud data warehouse. They require you to install your like engine on a certain hardware configuration. And that means that who we're testing, that being Firebolt, Snowflake, Redshift, and BigQuery, you can't
Mm-hmm.
fairly run them and submit their results to ClickBench because you can't get Snowflake on like a C6A Metal EC2 instance. Um, and Firebolt announced that we're moving in that direction last week. So soon we actually will likely be submitting results to ClickBench. But we also wanted to do a benchmark that compares the true cloud data warehouses, and you couldn't do that previously.
Yeah, no, I think that makes a lot of sense and great insights from both of you. Also, since we are on this topic, I would love to know a little bit about how does Firescale address all these concerns that we're kind of talking about, Igor, and what you all have kind of mentioned, and what did you guys do it differently when designing Firescale that it is the most innovative way to do the benchmarking, and what all things that you all have kept in mind? Because there's a lot of I would say there are a lot of things that you would need to consider when you're kind of looking at benchmarking, and then it's a process which needs testing. It needs a lot of back and forth, and then various things that you all have to keep in mind. So curious to know the concerns, how you all are addressing that, and how have you all done it differently.
No, that's again, another great question. So maybe just walk you through the evolution and how we went about creating a new benchmark, if you will. So first of all, kind of we had to pick a data set that we're going to use for these benchmarks. And so we
Hmm.
explored various data sets and we settled on AMP which is really kind of the data set, I would say, benchmark that was designed and tailored towards the analytical workloads. And it's modeled using kind of dimensional modeling technique, which is kind of very common for analytical workloads. And it contains, I would say, various data points and data sets like user behavior, geography, devices, search data, which is kind of something that users can really relate to. The second thing that was very apparent to us is that rather than us coming up with a set of predefined queries that perhaps are skewed towards what we would like to demonstrate, we said, why don't we actually go and try to profile our existing use cases and scenarios, what our customers actually and users exercise during POCs, prospective evaluating our technology, as well as running in production. And so what we've done is we profiled all of the queries that we see in Firebolt, and we looked into various, I would say, query patterns that users exercise, not necessarily into the actual query, but query pattern. And think of that as kind of group buys and aggregations that people do, filters that people apply, windowing aggregations or windowing functions, if you will, complex CTEs, if you will, subqueries, joins, and so on. And so we really came up with, based on that kind of evaluation, we came up with a set of 25 queries that represent really various workloads that people run on our platform. And these queries kind of vary in complexity from simpler queries, if you will, all the way to very, very large complex queries. And I would say the complexity of these queries is much larger than what we've seen in some of the standard benchmarks that you just mentioned earlier, TPCH, TPCDS, and others.
Right.
And so we really purposely went kind of beyond just to come up with something that is really simplistic, to really demonstrate what the technology is about, as well as kind of try to get a real life scenarios and try to compare how actually Firebolt performs for those. And now, as we went about this, like for example, one of the queries that we put out there contains 50-way join, if you will. So it's really a complex query.
Very important.
And obviously, the AMP lab data set that came kind of out of the box didn't actually allow us to run those queries. So we had to actually expand AMP lab data set to add additional data sets as well as additional entities, if you will, that we can actually execute these queries. And then maybe last point about this is that we believe in transparency, and we wanted to make sure that everyone can actually reproduce these results and run these kind of workloads and queries by themselves. So we published both benchmarks as well as all the queries that we profiled on GitHub, allowing everyone to really try run these benchmarks and kind of against different systems and try to reproduce and get similar numbers.
I love it. How obviously that is one very important point that you've mentioned, Igor, is you'll have also published all the queries on GitHub, and people can actually go out and reproduce, the results as well to see the results firsthand themselves, and they can try it. So that's fantastic. Cole, what would you like to add on this one?
Yeah, I think the main thing is that we really were diligent in trying to keep things like fair and honest and not like departing from doing an accurate measurement. I think it's something that it's easy to be skeptical of or accuse a vendor of doing when they publish a benchmark is like cooking the books or cherry picking queries, or
exactly
you run it one time and then you go tell the engineering team, please go optimize all of these queries before we publish this. None of that is what we did. The benchmark when we devised Firescale was originally just for internal purposes. We used it to make sure like releases didn't have regressions. It was like a suite we ran before doing a release, and I was like, well, now that we've got this and we trust it, like let's use it as our benchmark. And there was genuinely a day where it was in between the decision to run Firescale on other vendors and me actually going out and doing it. We were like a little worried. We're like, how are they going to do? How do we stack up? Like, we don't know. And it would have been really concerning and bad if it wasn't good. But like, we just ran with it, and what the results were is what they are. And we really have made sure not to take any steps that would be in bad faith in trying to get this benchmark out the door.
Yeah, no, I love it. That's exactly what I always say when it's, fair and transparent, and, you'll keep it for the community where they can go out and try and, obviously get the results themselves. That makes it much more interesting. And that is something, a piece where they'll believe so much, and they would want to, obviously, keep learning from that as well. But since we are here, I'm obviously curious to also see the numbers. I'm curious to see the results as well, and I'm pretty sure our audience would also love to see that. I don't know how, but if y'all have any way y'all can give us a sneak peek, maybe Igor, we have us now a sense at least of all why benchmarks and how Firescale was built. But do you mind sharing a little bit of the results and what did you guys observe? Anything of that sort?
No, absolutely. So I have a deck that let me actually share that in a second. But maybe before we go there,
Yeah.
speaking of transparency, I just want to mention that we published, as mentioned, like everything into GitHub, as well as we published every single query, as well as the results of those executions across different vendors. So full
Yeah.
transparency, whatever we're going to show right now is going to be aggregated view. However, there is a lot more details on both in the blogs that we published as well as in the GitHub repo that we published. So with that,
Fantastic.
let me share my window, and if you can confirm that you can see my screen, that would be great.
Yeah, we can.
Okay, awesome. So let us walk you through the results. So first of all, as we mentioned, the methodology about the benchmark, maybe two things to highlight is that we had two runs that we tried to simulate. One is a power run, which means that we run queries sequentially one after the other one, just to get a sense of what the raw performance of various systems look like. And the second run was really about simulating real life world scenario, which is how do you actually run something or that workload concurrently, simulating like multiple users kind of coming into the system and running their workloads against the backend and data infrastructure that is provisioned. With that, first let's zoom out and try to see how do the results look like. So you see the a simple just graph that we built that contrasts both how long it takes to run the workload as well as how much does it cost to actually achieve that performance. So on the x-axis, we see kind of slower and faster angle, as well as on the y-axis, we see the actual cost that takes to perform or execute that particular workload, specifically Firescale. As you can see by glancing at this, kind of the right-hand corner, that's kind of the fastest as well as the least expensive solution out there. And Firebolt, pretty much all the configurations that we try to validate and execute beats the existing or other vendors that we validate against. Let's dig deeper into the actual results. So there is, like as we spoke about, there is just a raw performance, if you will. And on the x-axis, you'll see kind of different configurations that we use for different vendors, trying to basically get a sense how does actually raw performance look like compared against all these vendors. On the left-hand side, first one, you'll see different configurations of Firebolt, and then followed by Snowflake as well as Redshift and BigQuery. Just by looking into these numbers, you can see that kind of Firebolt pretty much beats everyone in the range of 3 to 4 to 5, all the way to perhaps 17 and 20x performance difference between Firebolt and other solutions that are in the market out there. Now, when you look into how much actually users pay for the performance that they are getting out of the system, the numbers actually look even more compelling.
Right.
When you contrast the price performance characteristics, which is ultimately what the users need to worry about. It's not just how much you're getting performance out of the system, it's also how much you are paying for that performance as a consumer, if you will. And in this case, you can see that the story becomes even more compelling. And when we compare price performance difference between Firebolt and other vendors, that ranges anywhere between 9x, 10x against Snowflake to 17, 20x compared to Redshift and a lot more against the BigQuery. Now, where things becomes even more interesting is you can say, okay, so 10x, obviously it's significant saving for that performance. However, we also try to kind of shift things around and say, okay, so Firebolt is faster than other solutions out there. How about if we try to get to the same or similar performance characteristics that Firebolt provides and see how much do users need to actually pay to achieve that performance in other solutions. And you see here we compared Firebolt against Snowflake, and you may ask why is Redshift and BigQuery not on this graph? And the reason being is because we were actually not able to, no matter how much compute capacity we dedicated, we were not actually able to get to anywhere close to our performance characteristics or performance characteristics that we were seeing within Firebolt. And then in case of Snowflake, you see that they are not able to actually get to the same performance characteristics. But as you compare kind of to that similar performance characteristics, users need to pay significantly more to achieve the same performance results or similar performance results. Now let's dive into the actual concurrency run or simulating that multiple users running their queries against the backend system or the data infrastructure that's provisioned. Here we can see actually, again, very, very interesting data point. Just as a data point, what we've done is we try to simulate maybe 60 users coming at the same time into the system and running concurrently their queries, one after the other one. And you can see that when you measure the throughput of the system that you get in that concurrency scenario or a simultaneous user scenario, Firebolt significantly provides better throughput compared to other systems that are in the market, ranging from 5-6x more queries that can be run compared to Snowflake, all the way to 10x compared to Redshift. Now, interesting data point is not every company or not every application has consistent workload coming into the system, meaning that you have kind of variable concurrency needs throughout the life cycle of an application. So what you really want to see from your data infrastructure that it's able to scale and address that variable concurrency needs or different throughput needs, if you will, from the system. This is where we try to run various configurations to simulate basically how does the concurrency scale with the increase in demand. And you can see that Firebolt and Snowflake have pretty much kind of linear scaling from that perspective, where Redshift actually lacks such capability. However, when you compare Firebolt and Snowflake, you see a lot more throughput being available in the system compared to, and you can get the higher throughput scales in Firebolt compared to Snowflake.
Right.
With that, I think those are the numbers that we had to share.
I think first of all, Igor, those are thanks for walking us through, sharing all those results. Looks like you are doing something pretty impressive. Um, but I have a follow-up question. What do you think? What does it really mean for the customer in real life? With all the results, obviously, cost plays a very important role, and these factors obviously are super important. But what does it mean for the customer, and how do these results impact what they are trying to do?
Oh, that's a very good question. So maybe a comment, just a reminder that Firescale was designed with a real life workload, kind of something that we see, we've seen from our customers running their production. And based on that, we think that these results unambiguously prove that Firebolt is the solution and data infrastructure for companies that are looking to build modern data-intensive AI apps. We all are witnessing AI getting inroads within organizations and enterprises with the coming way of AI agents and related applications. Companies really need a way to scale their data infrastructure to support those AI scenarios while always keeping the cost under control. So efficiency is very, very important. And then, as Firescale demonstrates, Firebolt is far superior to kind of competitors such as Snowflake, Redshift, and BigQuery, and is able to deliver on those low latency, high throughput, and by far offers the best price performance characteristics.
Okay, that's pretty interesting from the customer point of view as well, because it kind of covers a good ground for the things that they kind of consider as well before going out and picking up a solution. Cole, do you have anything to add when we talk about customers, but also the results look
Yeah,
like
I
phenomenal
think
there?
I'd encourage considering like the true low latency of Firebolt for these like real world workloads like opens new doors. You can build things that you wouldn't have previously thought to build on top of SQL. Like rich user facing interactive applications can run with Firebolt as a backend. And then more importantly, though this isn't really shown on the benchmark, is Firebolt is a data warehouse. Like this is not some query accelerator with limited functionality. And so the fact that you could use Firebolt for this really low latency, really performant, lower cost analytics, but also as your true data warehouse, truly reduces total cost of ownership more than even the price performance chart would tell you. And like, yeah, price performance might be 8x or 10x better, but this also saves you on ETL pipelines. It saves you on needing to run a query accelerator on top of that. And your true total cost of ownership may be reduced 20x or 25x when you consider time, effort, pipelines, multiple systems, the time and effort involved in setting it up and maintaining it. It's just a lot less complex and a lot faster.
That's a great point, Paul. Maybe just to add, it's really like traditionally data warehouses have not been seen as kind of low latency, suited for low latency scenario, where we are now bringing those low latency inside your data warehouses. And so you enjoy your kind of robust data warehousing capabilities, such as the ability to run complex queries, ACID compliance, and so on. And you enjoy the low latency capabilities.
That's very good point there, Gaur. Cole, I would also love to, obviously see Firescale in action. Do you mind showing us more of how it all works, and how easy is this for customers to run and validate on their own? If you don't mind, we would love to quickly see a demo as well for Firescale and how it all works.
Yeah, let me share my screen. I'm going to open up VS Code where I've got Firescale loaded up.
Okay.
Hold on one moment.
Yeah, you just need to use the present below,
yeah,
and then we can
I have 1,000 windows open, so I just had to go find it.
All right.
So welcome to the Firebolt benchmarks repo. So you can find this on GitHub. It's fireboltdb/benchmarks. This is actually two benchmarks. So this is both two clients rather. We have K6 and we have Python. So Python was what we used to benchmark power runs, and then K6 was used to benchmark concurrent runs. To set it up, you're going to clone this GitHub repo. You're going to go create a credentials file that's a copy of this sample credentials file. This just is where you provide all of your access tokens, usernames, passwords, etc. for your vendors. I'm not going to open this one up because we've got all of that in there. And you then run a couple install commands, like you do your pip install requirements. For K6, you're going to do an npm install, and that's all you need to do to get running. You can see up here we have all of our queries set up, so I can open this benchmark.sql. So this is the SQL queries that we're running on Firebolt, and you can just go look at this. So that's the full file. You can see as we start scrolling down, these queries start getting quite complex. We've been looking at this one query for a while now. It's a 18 CTE many-way join query, and it keeps going from there. There's not enough time for you to walk through every query here, but what I can do is kick the run off. Do we want that?
Yeah, would love to see that for sure.
Right. So I'm using Firebolt, Snowflake, and BigQuery. I'm just going to kick this run off, and we're going to track their progress. So there's 25 different queries. We're going to run each query 5 times to gauge warm runs on them, as well as cold runs. So in our analysis, we only looked at queries, the runs 2 through 5 of each query, rather than query 1 as well. And you can see we're going to get running. We hit query 10 is a particularly compute-intensive query in this benchmark, so that'll be a bottleneck for a moment. And then we're going to keep going.
This is interesting.
Yeah, so I threw this together last night just as a simple way to visualize progress across this benchmark. We were not using this progress bar when we were doing any measuring. I just wanted to make it look good for the broadcast. But
yeah, exactly.
It's very satisfying to watch the bars creep from left to right as we go through queries. And so I think it's pretty visually evident which platform is running the fastest right now. Like, even without going and doing a bunch of analysis on the results, Firebolt is
Yeah,
done.
exactly. That was fast. Yeah.
Yeah, and what's going to happen is you're going to see Snowflake and BigQuery both. The queries get more complex as we go from 1 to 25. So
Hmm.
it's going to stay this slow for these other vendors. And Firebolt was just able to, through a number of different optimizations and eliminating scanning data,
Yeah.
compute that benchmark very, very quickly. And I should also say, by the way, I'm using for this demo, a compute optimized medium engine in Firebolt, which I believe has a enterprise list price of $2.80 per hour.
Yep.
For Snowflake, I'm using an extra small warehouse, which is $3 per hour. And BigQuery is just
Okay.
standard BigQuery cloud, serverless with no reservation. Generally, this means that it's going to take about a second per query, and that's what BigQuery is designed to do. So,
Hmm. No, thanks for that information. It obviously helps us to understand uh, in various categories how you're kind of running it. So yeah.
do we want to look at anything in this benchmark? I can walk you through kind of the Python client. It's the way it works is we have our main files, we have our connectors for different vendors. Up in this benchmarks folder, we have all of our different queries. So, for example, I can open up the Snowflake benchmark.sql, and now this is adapted to Snowflake syntax. Because
Hmm.
not every system is exactly the same. Different systems need like array ag or array join or something like that. But you can
Right.
go add to this, or if you don't care about certain queries or you want to use your queries. This is designed to be extensible, modifiable. So if you're curious, you can say, well, I don't really care about how query 23 works. You can just delete that from every runner. If you
Yeah.
want to test a vendor that's not here, all you have to do is go set up a connector. Um, it's actually not that hard. We're just using the vendor provided Python clients, and with that,
Yeah.
you're good to go. Sorry, I'm trying to fill time while Snowflake
Yeah,
is
exactly. No,
running.
yeah, no, it's good information in terms of how you all have been putting this together and on what basis you all have come up with the results as well. It's always good to and that's why I wanted to make sure if we are obviously going and talking about something like this, we have everything in place in terms of what are the results that you all have seen, how transparent you all have been. Can we also see the demo, because I want the audience to get a 360-degree view of the Firescale and how it actually works. I'm also obviously, after this, I would love to know about what's next that's kind of coming up, and how can the users make the most of it as well. And I know there's an environment that where they can do everything, like GitHub is there, they can go out and obviously try and test it themselves. So nothing better than that. But okay, quick question. So for Igor and Cole, both of you, how long did this benchmark take to how long did it take for you all to put this together?
Uh, Igor, we started planning on doing this in December, yeah.
Oh wow.
Yeah, I think that's about right. So I think like if we launch, maybe high level is if we launched Firebolt and make it basically in September, October timeframe, we wanted to really start looking how do we actually demonstrate whatever we talk about for our users, what the core value propositions for the technology is. How do we actually create that proof point? And so around November, December timeframe, we started really profiling and looking what's the best methodology for us to actually go about and how do we, because typically people are very on the benchmark, so we wanted to make sure that we are authentic as well as that we really try to mimic the end user scenario and how we see customers use our technology in production environment. And so it took a little bit of, I would say, brainstorming sessions to figure out what that methodology needs to look like. And ultimately we came up with it, and hopefully you guys like it.
Yeah, no, I love it. If it's just like 4 months, obviously you all have put massive, features. You all have tested it at massive scales as well. Like talk about each of the grounds that you all have covered, about the 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 cost, which is like a big pain point for a lot of enterprise leaders out there. They kind of focus a lot on cost, scalability, the timing as well, where Firebolt was like just right now as well. Firebolt did get through and surpass obviously Snowflake and BigQuery. So that's pretty important. So well done on that. Really great work that you guys have done, and really made it public for the audience, which is another big thing, which not every vendor would do.
Yeah.
So
And maybe like you actually mentioned that as a question. So let me actually take this and talk a little bit kind of what's the future of Firescale. So are
yeah,
we
sure.
done, or are there kind of additional things that you want to do with it? So first of all, I would say what we published is really a first step for Firescale. There is multiple kind of dimensions that we're going to expand Firescale at. First one being not every database or data warehouse, for that matter, comes with the same data set size, if you will. What we
Yeah.
published actually is the data set of 1 terabyte, as you mentioned, of AMP data. We also
Mm.
want to go bigger as well as smaller. So we want to offer various insights for people to get insight into how different solutions work with the smaller data sets as well as larger
Yep.
data sets. So the goal is really to publish both kind of 100 gigabytes data set results for that data set, as well as something around the 10 terabytes or so. So going bigger scale and larger data warehouses. So that's one way. So both power run as well as concurrency runs will be done on those scale factors. The second
Yep.
one is really around we publish the results and with solutions such as Snowflake, Redshift, and BigQuery. We all know there is few other solutions out there, cloud data warehouses, so we'll likely expand the comparison so people can get full breadth of solutions out there and kind of how Firebolt as well as every other solution flares next to each other. And then maybe last but not least, we do have very great customers that work with us, and in some cases, customers like have actually agreed to give us their workloads, and so we can actually run those real workloads against other competitors as well. And so wherever possible, and where we get approvals from our customers, perhaps with some of the masking, we will try to publish some of those workloads officially on as part of Firescale, so we can actually demonstrate how Firebolt compares to other solutions out there.
Okay, this is fantastic. You got from obviously different sizes of data sets to obviously running benchmarks on various places, and then obviously with different competitors, kind of is a good deal for the enterprise leaders and also the users out there. So thanks for sharing that in a little bit about the future as well. Getting back to Cole, in your I see the results are here already, or over to you, Cole.
Yeah, so the benchmark client actually generates this for you. So if you just want to do some very quick and dirty analysis, it's right here in
Hmm.
this PDF. We also have a results.csv, and this was the thing that we're actually using to power our analysis. I also realized I didn't make the caveat. I'm running this off of my laptop.
Yep.
When we were running this for real, we were running it off of an EC2 instance in Northern Virginia to make sure there was no network latency.
Yeah.
But yeah, with these visual results, you can also see it. So for this run today, it's Firebolt took 1 minute and 11 seconds to do this benchmark. Snowflake took 6 minutes 28 seconds. BigQuery took 5 minutes and 12 seconds.
Right.
And if you recall, Firebolt also it's the least expensive engine we're running with this much better performance. So,
Exactly.
and you can look at how each query did. You can see we're pretty consistently winning across the board. BigQuery ends up
Hmm.
doing query 10 a little faster, I think. But that's about it. So that I think is a pretty stark demonstration of how Firebolt does on a benchmark like this. But you saw the queries, you saw the runner, like it's all out there in the open. You can do it for yourself.
Yeah, no, I think this is fantastic, and thanks, Cole, for giving us a deeper dive into it. We'll make sure to also share the link in the all the other stuff. I know you've written like a detailed blog on it, so we'll also make sure to share it with our audience so they can deep dive themselves. They can try it themselves, and feel more confident about the Firescale benchmark that y'all have put together. So that's awesome. One more quick question before we wrap up. What are y'all like the final thoughts you both have, Igor?
Yeah, maybe like I would like to maybe leave our audience with three key takeaways from my perspective. Firebolt is the next gen cloud data warehouse for data intensive AI applications. Maybe the
Mm-hmm.
second point is really around the generative and agentic AI. We've all witnessed kind of wide adoption of these new applications, if you will, out there. And they really exacerbate the need for low latency as well as high concurrency. In case of AI, users really don't have control over what type of queries are being sent to the backend system or data infrastructure, as well as the number and volume of these queries being sent. And so low latency, high concurrency needs are even kind of exacerbated and paramount problem, if you will, as people think about deploying these generative and agentic AIs. And maybe last but not least, as demonstrated by Firescale, Firebolt offers superior price performance characteristics compared to other systems that are currently in the market.
That's awesome. Cole, what do you think?
Yeah, I'd say like this project's not done. You know, we announced Firescale, but we have plans for it. And if you notice something wrong, or if you have a suggested improvement, or you want to throw something into this repo, it's open, it's publicly accessible. Like, reach out to me directly, open a pull request, whatever you want to do. Like, we want this to be real and accurate, and we welcome and invite community feedback. So please go get your hands on, try it out. We'd really like it.
Well, there you have it. Firescale is your, and it's real, it's reproducible, and it proves that Firebolt is obviously in a league of its own when it comes to powering data intensive AI apps at scale, like Igor mentioned. But once again, thanks, Igor and Cole, for joining us today. Thanks to our audience as well for tuning in. I can't wait to keep talking more. I'll obviously be diving a little more deeper into Firescale. I'll be obviously reading all the. I'll be reading the report, the blog, the detailed blog that y'all have shared as well, and share it with my audience as well for them to understand more about Firescale. But obviously, this was much needed. I wanted to, obviously talk to those makers who have, come up with this. So thanks for doing this. I really appreciate the time, and we'll keep the conversation going for our audience. And again, congratulations on putting such a great report together.
Thank you.
Thanks for having us.
Thank you. Thank you very much. Thanks everyone for joining us today.